You know, you look up at the night sky and it seems so peaceful, so permanent. But what if one of those little points of light just exploded? I'm talking about a supernova, one of the most violent events in the universe. Imagine a new star appearing, one so bright it outshines the full moon, casting shadows at night, even visible during the day. It's a mind-blowing thought. But what if one happened in our own cosmic backyard? Would we be treated to the greatest light show in human history? Or would it be lights out for life on Earth?
That's really the big question, isn't it? And that's what we're going to dig into. We're going to look at which stars are the most likely candidates to go supernova near us. Then we'll get into the real threat they pose, and trust me, it's probably not what you're thinking. And finally, we'll look at the proof that our planet has actually been hit by this stuff before. So, light show or lights out? Let's figure it out.
All right, first things first, who's on the watch list? Which of our stellar neighbors could actually be a ticking time bomb?
Okay, so here are the main suspects. And you'll probably recognize a few of these names if you're a stargazer. We've got Antares, Rigel, and of course the big one everyone talks about, Betelgeuse. But here's the key thing to wrap your head around. Nearby in space is, well, it's not nearby at all. The closest one on the list, IK Pegasi, is 150 light-years away. That's almost a quadrillion kilometers. So yeah, while they're on our cosmic watch list, they aren't exactly next door.
And just to give you a sense of scale, let's talk about the real heavyweight champion of our galactic neighborhood, Eta Carinae. This thing is an absolute monster, a star system that's up to 200 times the mass of our Sun. When it finally goes, it's not just going to be a supernova, it's going to be a hypernova. But, and this is the important part, it's 7,500 light-years away. So while it's going to be an unbelievable show for some future generations' telescopes, it's way, way too far away to hurt us. And that helps us understand what the real threat mechanism is.
So if it's not the blinding light or the wave of heat that's going to get us, what is it? Well, the real danger is completely invisible. It's a quiet, delayed attack on the one thing that protects all life on this planet, our atmosphere.
Okay, so here's how this chain reaction would go down. The star explodes, that's step one. But that explosion acts like a colossal particle accelerator. It launches these things called cosmic rays out into space. Now these rays travel for thousands of years, and if Earth is in the line of fire, they eventually slam into our upper atmosphere. That collision kicks off a whole bunch of chemical reactions that literally shred our protective ozone layer. And once that shield is gone, we're left exposed to a whole lot of harmful UV radiation from our own sun.
So what are these cosmic rays exactly? Honestly, the best way to think of them is like cosmic buckshot. They're tiny particles, mostly protons, that have been supercharged by the supernova shockwave, getting them moving at nearly the speed of light. So you see, it's not the initial flash of the explosion we have to worry about, it's this relentless storm of high-energy particles that comes later. That's the real weapon. Now, how these particles actually get to us makes all the difference. Space isn't empty, right? It's filled with all these tangled magnetic fields. So this gives us two basic scenarios. On the left, you've got case A. That's the worst case. It's as if the magnetic fields create a kind of funnel, focusing the cosmic rays into a direct, concentrated beam that hits us head-on. But the much more likely scenario is case B, on the right. Here, the fields are all jumbled up, which scatters the particles. They still get here, but they arrive as a much more diffuse, less intense wave. And here's what those two scenarios would actually do to our planet's sunscreen. In that absolute worst case, direct hit scenario, our ozone layer could be depleted by over 60%. Just to put that in perspective, the ozone hole we worry so much about today is only a few percent depletion. Now, even in the more likely scattered scenario, case B, we're still looking at a 25% loss. That's a huge blow to the biosphere.
Okay, I know this all might sound like some doomsday computer model, but here's the kicker. It's not just a theory. Scientists have found cold, hard evidence that Earth has been on the receiving end of this cosmic fallout before. And the proof isn't in some simulation. It's buried deep in the Earth's crust. And all that evidence boils down to one very specific, very special isotope, iron-60.
Iron-60 is the smoking gun. It's a radioactive type of iron that's pretty much only forged in the heart of a supernova. It doesn't form naturally here on Earth. So when scientists started finding layers of this stuff in ancient deep-sea crust, and even trapped in Antarctic snow, well, that was it. It's a literal cosmic fingerprint. Undeniable proof that material from exploding stars has rained down on our planet in the past.
And this timeline shows it wasn't just a one-off event. We see a clear deposit of iron-60 from about 8 million years ago. But then there's another much stronger signal from around 2.5 million years ago.
That one is thought to have come from a supernova that was only about 160 light-years away, well within that zone of influence we're talking about. So, Earth has been hit before and, well, we're still here. So, let's pull all these threads together. We've got our suspect stars. We know the real danger comes from cosmic rays stripping our ozone, and we have solid proof that it's happened before. So, what's the final verdict for a future event?
Well, the really critical thing to understand is that our idea of the danger zone has changed a lot. The old thinking focused on the initial blast of radiation, which gave us a pretty small lethal distance, maybe 33 light-years or so. But the new understanding, which focuses on those long-term effects of cosmic rays, has expanded that danger zone way, way out to over 160 light-years. The area of potential harm is just so much larger than we used to think.
And the danger doesn't just stop up in the ozone layer. See, when those cosmic rays hit our atmosphere, they create this shower of other particles that actually makes it all the way down to the ground. So a nearby supernova would seriously crank up the background radiation we're all exposed to every day. And, as you can see from this graph, that effect would linger for thousands of years. It wouldn't be an instant apocalypse, but it would almost certainly mean higher rates of things like cancer and genetic mutations for everything living on the surface. Yikes, that sounds pretty serious. And we know for a fact there are stars sitting inside that new, bigger danger zone. So, should we be worried? What does this all mean for you and me right now? The bottom line is this, and this comes straight from the research. None of the stars we know about are close enough to cause us any serious harm when they finally do explode. So, instead of an extinction event, we, or at least our distant descendants, will be treated to the most unbelievable sight. An object in the sky as bright as the full moon, visible both day and night for weeks on end. It would be a truly once-in-a-civilization event. So the answer to our question, light show or lights out, is kind of both. A nearby supernova is a genuine cosmic hazard, no doubt about it. It's a powerful reminder that we live in a pretty violent universe. But for us, for anyone alive today, the known threats are just too far away to be a problem. So instead, they hang up there as a promise. The promise of one day witnessing, without a doubt, the greatest light show in all of human history. Kind of changes how you look up at the stars, doesn't it?